Hello everyone. The second tool for the improvement phase that we're going to talk about it in this video. Again, this is Dr. Mahmoud Al-Odeh. And the tool that we're going to talk about it is the solution design matrix. And this is really important. What we're going to talk about it first, we're going to give you an overview on what is this tool, and then we'll give you a case study that we could implement this tool. So we're going to mix between theory and practical so you could better understand this tool. So it's a tool to organize the alternative solutions. So whenever you have a different solutions, this tool will help you to organize it. It is similar to a QFD. If you remember the QFD where we have a different rooms and different opinions and we start breaking, it is very similar. So if you still remember the QFD, it would be easy for you to understand this. This tool will help to compare how the proposed solutions compared with the existing system. So you say, okay, here's the existing system, here's alternative one, alternative two, and then you compare what you have in the existing system to the new solutions. All right, let's talk about the steps in order to create this solution design matrix. One is determine the key criteria. So first of all, you say, okay, what is important for me to study here? What do I need to do in order to evaluate them? So you have to have a criteria in your mind, what the different features that you want to investigate, you want to study. And then write them on the left-hand side of the matrix. So you list all the options, all the features on the left side. And once you have a team and you form a team, you share with them, this is what the features that are important for us. And then you look into the different alternatives. You bring your current system, the existing process, in the new process A, new process B, new process C, whatever you think. And if the benefit or the feature is existing in the current system, you give it a zero rating of 0. If the new design, if they don't have that feature, you give it a -1. If it's similar to the existing system, you give it a 0. If it's better than the existing system, you give it 1. Again, -1 indicate worse than existing design. 0 indicates same as existing design, and 1 indicates better than existing design. And then the next step would be determine the importance rating. So you say, okay, well, we have listed all these features, but we don't know what is important. So you bring the team, say, okay, scales 1 to 5, 1 being not important, 5 being very important. How would you give that you need a faster car based on 1 to 5? And then your team will give the importance. Now then find out what the sum of the positives, sum of the negatives, sum of the zeros. Weighted sum of positive and weighted sum of negatives. And I'll share with you how you could do this in just a second with the example. It would be more important to share with you this example. The project which has the highest value, this is the conclusion of the whole system, the whole tool that we're going to use here. The highest value of weighted sum of positive minus the weighted sum of negative will be selected as the best option. All right, let's go ahead and talk about this example, a case study. We have a case study for buying a new popcorn machine. And the first thing that you want to do, list down what the features that you want to be in this solution, in this process. And we have time to cook, how long it will take, percentage of cooked corns, taste, cost of material, complexity of manufacturing process. And then the second, we have alternative A or project A and alternative B. And you have the existing process. So all these features are in the current system. So you could put 0. And now about the time to cook. And if you selected alternative 1, that maybe takes too long. So that's where you give it a -1, a -1. And now For alternative B, it's the same, so we're going to give it a 0. Next, percentage of cooked corn, existing system, existing process, 0. Process A or alternative A or project A, it's the same. For alternative B or project B, this is better than the current system, so we give it a 1. Next, taste. It's 0 because it's already exists in the system. In alternative A, you give it 1. Alternative B, you give it 1 because it's better than the system, the current system. Cost of material, 0 for the current system. 1 for option A, minus 1 project B, which means it's worse than the existing system. Last feature here, complexity of manufacturing process, minus 1 for alternative A, and a 0 for alternative B. And of course, 0 for the existing system because it has that feature. Now, the next is the importance rating. You talk to your team saying 1 is the lowest, 5 is the highest. Rank these features based on what you think is the most important. You meet with your team, most of them will say, okay, time to cook is 4. It's really important. Percentage of cooked is 3. Taste is 5. Cost of material 3. So you could have the number twice or 3 times. You could repeat the number again and again. And complexity of manufacturing is not really important, so we'll give it a 2. Now, the next phase is to find the sum of positive, sum of negative, sum of zeros. So for the current system, we have 5 zeros, 0 positive, 0 negative. For alternative A, we have 2 positive and 2 negatives and 1 0. Or for alternative B, we have 2 positive, 1 negative, and 3 zeros. Okay, now let's find the cumulative or the weighted sum of positive. The weighted sum of positive would be 8. And where is the 8 coming from? 1 right here times 5 plus 1 times 3. 1 plus 1 times 5 would be 5 plus 1 times 3 would be 3. 5 plus 3 would be 8. Weighted for the sum negative would be minus 6. Negative 6. That's coming from minus 1 times 4 minus 1 times 2. Add these together. Minus 4 minus 2. That would be negative 6 in total. For alternative B, we have 2 positives, 1 negative, 3 zeros. So if you notice the 0, it's not going to impact anything. The 0 is not going to impact the total weighted. 1 times 3 plus 1 times 5, that would be 8. For the negative, we have 1 minus 1 times 3, that would be only the one we have in here. So that would be minus 3. So if you add the overall weight, 8 minus 2, that would be 2. Sorry, 8 minus 6, that would be 2. On alternative B would be 8 minus 3 would be 5. That would be 5. So based on this project, what we could see that alternative B has the highest weight. Therefore, alternative B or project B should be selected. And that's what we call it, the solution design matrix. And now the next video that I'm gonna stop my video here, I'm gonna talk about design of experiment, and I'll see you in another video. Tune in.